This is problem number 5 from section 5.4. We're going to evaluate the following integral, and now we're going to be dealing with some trig integrals. Now, with the trig integrals, you're probably going to have to use some identities or use some reciprocal identities and stuff like that to get them in a form where we can take the antiderivative. So, if we take a look at our derivatives here, we know sine is cosine, so on and so forth. But we're really looking at the tangent one. Now, secant squared is the derivative of tangent, so the antiderivative of secant squared is tangent. So we're probably going to try to use this form right here, or we could even use the secant x equals secant tangent form. We want to rewrite this into one of those two forms so that we can actually do the antiderivative. Well, it just so happens that when we look at this right away, we see tangent squared. Usually when I see tangent squared, I think of the Pythagorean identities. So if we look at our Pythagorean identities, we can see that tangent squared theta plus 1 is equal to secant squared theta. So we can say that tangent squared theta plus 1 equals secant squared theta. That means tangent squared theta, if we subtract the 1 over, is secant squared theta minus 1. We can use this to our advantage because, like I said, with our derivatives, we have secant squared. The antiderivative of secant squared is tangent x, so we can actually find that. So if we can convert this into secant squared theta minus 1, we can use this antiderivative. And that's how we start the problem. So I'll hold those down at the bottom. We'll say that this equals the integral, the integral from 0 to pi over 4 of, we're going to replace tangent squared x with secant squared x minus 1 dx. So that's our first step, is replace tangent squared x with its Pythagorean identity version. And now let's take the antiderivative. Well, we know the antiderivative of secant squared is tan x. So we can say that this part is tan x. And minus 1, the antiderivative is minus x. And that's going to be evaluated from 0 to pi over 4. I'm going to slide these off to the side because we're done using those. Now we just need to plug those in and evaluate. Let's go tangent of pi over 4 minus pi over 4 minus tangent of 0 minus 0. So we can make this a little bit easier. Tangent of pi over 4. Remember that tangent of pi over 4 is sine of pi over 4 over cosine of pi over 4. Minus pi over 4. And we can do the same thing here. We have sine of 0 over cosine of 0 minus 0. When we divide, well, first off, sine of pi over 4 I know is root 2 over 2, and cosine of pi over 4 is also root 2 over 2. So I have that minus pi over 4. Sine of 0 is 0, so this just cancels out. Minus 0, that's gone completely. This is all gone. All I've got left then is that's equal to 1 minus pi over 4. And they'll probably want this combined together, so we can make this 4 over 4 minus pi over 4, and write that as 4 minus pi over 4. So they'll probably either take this answer or they'll take this answer.